For the last century, we have operated under the assumption that we know where we live. We teach our children that there are 8 planets orbiting a solitary star surrounded by a scatter of debris that fades into interstellar space. We believe the map is complete, but deep in the outer dark, something is breaking the rules. Beyond the orbit of Neptune, in the frozen wasteland known as the Kuiper Belt, there is a population of icy objects that are behaving impossibly. If you look at the solar system from above, these distant rocks should be pointing in random directions, scattered by billions of years of chaotic drift, but they aren't. They are clustered together. They swing out into the darkness and then curve back toward the sun in a synchronized formation, like a school of fish turning against the current. Astronomers have crunched the numbers on this alignment. The probability of this happening by accident, by sheer cosmic chance, is less than 0.1%. In the language of physics, that is not a coincidence. That is a signature. Something massive is out there. It is roughly 5 to 10 times the mass of the Earth. It is invisible to our eyes, and it is currently shepherding the outer reaches of our solar system. We are no longer asking if a 9th planet exists. We are asking why we haven't found it yet. Before we leave the known solar system behind, take a moment to secure your connection to this channel. We explore the universe's darkest secrets every day, and you don't want the algorithm to hide the next discovery from you. Now let's look at the ghost in the math. To understand why scientists are so confident about a planet they have never seen, you have to look at history. This isn't the first time gravity has betrayed a hidden world. In the 1840s, the planet Uranus was acting strangely. It was speeding up and slowing down in its orbit, defying the laws of physics as we understood them. A French mathematician named Urbain Le Verrier didn't need a telescope to solve the problem. He used a pen. He calculated that Uranus wasn't breaking the laws of gravity, it was being pulled by something else. He sent his coordinates to an observatory, and on the very first night they looked, they found Neptune. Neptune was discovered by math, not by sight. And today we are standing in that exact same moment again. In 2016, researchers Constantine Batygin and Mike Brown at Caltech ran the simulations that changed everything. They proved that a distant, highly elliptical super-Earth could naturally explain the strange clustering of those Kuiper Belt objects. Their model described a world that takes between 10,000 and 20,000 years to complete a single orbit. It sits hundreds of astronomical units away, so far that the sun is just a bright star in its sky. This hypothetical planet isn't just a mathematical fix. It fills a massive hole in our understanding of the universe. When we look at other star systems, the most common type of planet we find is a super-Earth, a world larger than Earth but smaller than Neptune. Yet, our solar system doesn't have one. Finding Planet 9 would make us normal. It would be the missing link that connects us to the rest of the galaxy. For years, critics argued that the clustering might just be a bias in the data, that we were only seeing objects in one direction because that's where we pointed our telescopes. But in 2024, the evidence shifted from compelling to undeniable. A groundbreaking study focused on a specific group of unstable objects known as Neptune crossers. These are debris that dip into the giant planet's territory. By all accounts, they shouldn't exist. The gravity of Jupiter and Neptune is so violent that these rocks should have been ejected from the solar system billions of years ago. The fact that they are still there requires a stabilizer. Simulations showed that these objects can only survive if a distant, massive planet is anchoring them, keeping their orbit steady against the chaos of the inner giants. This finding reached what scientists call 5 sigma statistical significance. In the scientific world, 5 sigma is the gold standard. It means there is a 1 in a million chance that this is a fluke. It is the same level of certainty used to confirm the discovery of the Higgs boson. We have moved past the point of guessing. The math is screaming that without a massive gravitational anchor in the deep solar system, the architecture of our neighborhood makes no sense. So if we know it's there and we know how big it is, why is it so hard to take a picture of it? The problem is the light. Planet 9 is predicted to be hundreds of times farther from the sun than Earth. At that distance, sunlight is barely a whisper. The light has to travel all the way out there, bounce off the planet, and travel all the way back to us. By the time it returns, the signal is millions of times fainter than Pluto. Attempting to find it with a standard optical telescope is like trying to spot a black piece of coal against a black night sky from 1,000 miles away. This is why the strategy has changed. We are done looking for light. We are looking for heat. Even a frozen world retains heat from its formation. A planet 5 times the mass of Earth would glow faintly in the infrared spectrum. In a massive archival study completed in 2025, researchers stopped looking at the sky and started looking at the past. They combed through decades of old infrared satellite data, looking for any faint blip that moved while the stars stood still. They identified a promising candidate, a heat signature that tracks perfectly with the predicted orbit. It is faint, it is ghostly, and it is right where the math said it should be. But a blip in old data isn't enough. We need confirmation. Of course, until we have an image, there is always room for the bizarre. Science demands that we ask, what if it's not a planet? The sheer strangeness of the data has led some physicists to propose radical alternatives. Some suggest we aren't seeing a planet, but a primordial black hole, an object the size of a grapefruit with the mass of 5 Earths captured by our sun billions of years ago. If that's true, we will never see it with a telescope. We would only see the light of stars bending around it. Others argue for a massive disk of dust and debris that collectively mimics the gravity of a planet. And then there is the most unsettling theory of all, modified Newtonian dynamics, or MOND. This theory suggests that there is no dark matter, no Planet 9, and no black hole. Instead, it argues that our understanding of gravity itself is wrong, that at extreme distances, gravity behaves differently than Einstein or Newton predicted. However, each of these alternatives has a flaw. The black hole theory is statistically unlikely. The debris disk would need to be impossibly massive, and modified gravity struggles to explain the specific, sharp clustering we see in the data. The simplest, most robust answer remains a physical, solid world. We are now in the final phase of the hunt. The theoretical debates are ending because the technology has finally caught up to the math. As of 2026, the Vera C Rubin Observatory is fully operational. This is not just another telescope. It is a wide-field survey machine designed to scan the entire available sky every few nights. It creates a motion picture of the universe. Planet 9 is incredibly faint and moves incredibly slowly. To a normal telescope, it looks like a stationary star. But to the Rubin Observatory, which will stack images over weeks and months, that faint dot will detach itself from the background. It will crawl across the frame. The search area has already been narrowed down. We have the candidate from the infrared data. We have the 5 sigma confirmation of the orbital clustering. And now we have the ultimate camera pointed at the exact sector of the sky where the ghost is hiding. If Planet 9 is confirmed, it will be the discovery of the century. It would likely be a lost giant, a 5th major planet ejected during the violent youth of our solar system, trapped on the edge of the abyss. It would rewrite the textbooks, solving the mysteries of how our system formed and why we look the way we do. The solar system is bigger than we thought. The map we grew up with was incomplete. We are standing on the precipice of finding a new world, and when we do, we will realize that for all of human history, we have been sleeping next to a giant. If you want to be the first to know when that announcement drops, make sure you're subscribed and have notifications turned on. The discovery is coming, and you won't want to miss it.